In this video, we're going to try and derive the formula for the surface area of a sphere. So we would start out with our circle. The equation for the circle is given by this, and the idea here is to sum up all the surface area from 0 to r. So if you look at this one particular strip, the thickness associated with this one particular strip is dx. Let me just exaggerate and zoom into that one particular strip. So let me just exaggerate. Hang on. So the thickness associated with this one particular strip is dx. Now the idea here is that you start with dx, and then you somehow work out the arc length for that thickness, for the thickness of dx. Once you've got your arc length, so this is our arc length. Once you've got your arc length, then we need to revolve it 360 along the x-axis. So we would need to times it with two. We would need to times it with the circumference of a circle, and then that will then give us the surface area for one particular strip, and then we will need to sum up all the strips. So we will need to sum up all the strips from 0 all the way to r in the dx direction, and then that will then give us half of a sphere, and then later, right at the end, we can times it by 2 to give us a whole sphere. So let me just quickly run through this. So the idea here is to sum up all the strips. So once you've got, so you would start out with your dx. Once you've got your dx, you jump and work out the arc length associated with that dx, and then once you've got the arc length, then revolve this 360 along the x-axis. So we got to times it with the circumference of a circle, and then sum up everything from 0. Well, and then sum up everything from 0 to r dx. It doesn't matter if you don't understand it at this stage. Let me guide you through it. But roughly speaking, that's what we're doing. Okay, so we would start out with our dx. So the thickness associated with this is dx, and then the next step is to work out the arc length. So from our thickness dx, we need a way of working out the arc length. So let's try and work out the arc length. So let's say you've got a curve like this. Now the ds is this distance here. ds is this distance here, the true path of the curve. Now the true path of the curve is approximately delta x. Well, this is really us using Pythagoras, this bit here. So the true path is approximately this, and then we spend a lot of time learning about limits. So from here, we spend a lot of time learning about limits. Well, limits allow us to take it from this step to this step, because as you decrease, as you make delta x smaller and smaller and smaller, the length of the true path becomes equal to these two. So well, we spend a lot of time learning about limits. So limits allow us to travel from here to here. So the true path is equal to, up here is just approximately, but the thing is, as you decrease x, make it smaller and smaller and smaller, eventually you can say that the true path equals this. Up here is just approximately. Well, limits allows us to get from here to here. So once you're here, you've got this block equals this block plus this block. Divide everything by dx squared. So that will then take you to this, and then this you can rewrite it as this, because if you have a squared over b squared, that becomes this. So this will then become this. This here is just 1, and this here you can use the same technique and turn this into this. And then now square root everything, well, square root both sides. That will then give you this, and then times both sides by dx. So the true the true path is equal to this thing here. Okay, so basically the arc length. Hang on. So what's happening here? When you look at this, when you look at this, what's happening is that well, the idea is you sum up everything. If you look at the thickness associated with this one particular strip, the thickness here is dx. Let me just zoom in and exaggerate this. So the thickness here is, let's say we've got this one particular strip here. The thickness here is dx. So we start with our dx, and then by combining it with this thing here, then this whole thing here will then give us the arc length. So this ds here is this bit here. So we would start out with our dx here. We would start out. So hang on. We would start out with our dx here. So the dx is this bit here. So we would start out with our dx. We would start out with our dx. Combine it with this. That would then give us the arc length. So this thing here is this arc length here. So if you want to know the arc length from here to here, then you would sum up everything from 0 to r. But the thing is, we don't want to know the whole arc length. What we actually want to know is we've got a strip here. So we start out with our dx, and then from our dx we would work out the arc length. But the thing is, we don't want the whole arc length here. We just want this small arc length. Now once we've got that small arc length, then we would need to times it with the circumference of a circle. So that would then give us, basically we were revolving it around the x-axis. Then that would then give us the surface area for that one particular strip. Now if we want to know the whole thing from 0 to r, then we would need to use the integral here. Okay, so hang on. So we would start out with dx here. So hang on. So we are doing this. Hang on. We are summing up all the strips here. So if you look at the thickness of this one particular strip, let's look at this particular strip here. This is our dx. So we would start out with our dx. So this strip here is this strip here. So we would start out with our dx here. We start out with our dx here. Combine it with this, then that will then give us this arc length here. Once we've got the arc length, then we're going to revolve it 360 along the x-axis. So we need to times it with 2 pi. So hang on. So bear with me. We're going to sum up everything here. Once we've got our arc length, let's just look at this one particular strip here. This is our dx here. We've got dx. Work out the arc length, and then we would need to times it with the circumference of a circle. So the surface area of one strip is given by this. This is for one strip. So we start with our dx, combine it with this. That will then give us the arc length. That will then give us the arc length. So that would then give us the arc length. Once we've got the arc length, we would need to times with the circumference of a circle. So this is our circumference of a circle. This here is really the height. So hang on. So we are doing this all the way from 0 to r. Once we've got the arc length, we will need to times it with the circumference of the circle. But the height here is this y here. The height is this y here. So the surface area of one strip is given by this. Well, if you want to sum up all the strips from 0 to r, then the surface area, then the surface will be given by this. So what I mean by the surface is from here, from 0 to r. So we are summing up everything here in this direction. We are moving along in the x direction. So if you look at the thickness associated with this is dx. This bit here, combine these two, that will then give us the arc length. Once we've got the arc length, we will need to revolve it 360 along the x-axis. That's this bit here. And then we will need to sum up everything from 0 to r. So we need to sum up everything from 0 to r. Then this thing here will give us half of the sphere. Later on, right at the end, we're going to times it by 2. But we are currently here at the moment. I will continue from here in the next video. Okay?